These are notes from Mel Ham's Math 60 for Wednesday, April the 8th, section 7.6, page 647. Side note, the previous video was for Tuesday, April the 7th, but if you look at the title, it also said it was from Wednesday, April the 8th, so I apologize for that. Obviously that one was Tuesday, April the 7th, but this one is Wednesday, April the 8th. We're dealing with the Pythagorean Theorem here. Hopefully you've heard of that before. The Pythagorean Theorem says that if you have a right triangle, there's an angle that is a 90-degree angle, and we have sides A, B, and C. C is called the hypotenuse. It's the longest side. It's always opposite the right angle. The other two shorter sides are called the two legs. Then we have the relationship A squared plus B squared is equal to C squared. So for problem 15, we're given that A is 6 and B is 8. They're actually feet. I'm only going to write feet in the final answer. It says feet in the book, but I'll save it until the end. So 6 goes here, 8 goes here. So I have 6 squared plus 8 squared is equal to C squared. 6 squared is equal to 36. 8 squared is 64. 36 plus 64 gives me 100 equals C squared. So C is the square root of 100, which is 10. So 10 feet is the answer. 19, something similar, only you're given one leg and the hypotenuse. B is 9, C is 41, so we're looking for A. So plug into A squared plus B squared equals C squared. A squared plus 9 squared equals 41 squared. 9 squared is 81. 41 squared is 1681. You can just punch that in your calculator. Subtract 81 on both sides. A squared equals 1600. A is the square root of 1600, which comes out to be 40 feet. 25, you're given an isosceles right triangle. An isosceles triangle has two sides that are the same, so the two legs are equal in length, and you still have the hypotenuse. So you're given a distance of 3.2 feet. That means two sides are 3.2 because it's isosceles. So that means I put 3.2 for A and B way back over here. So 3.2 squared plus 3.2 squared is equal to C squared. 3.2 squared is 10.24. Plus another 10.24 is equal to C squared. Add these up, you get 20.48 equals C squared. So C is the square root of 20.48. You can punch it in your calculator. 4.53 feet rounded to the nearest hundredth. Problem 29, you're given a square that has a diagonal of length 10 inches. So I call the two legs x. They're equal, x, x, and 10. So x squared plus x squared equals 10 squared, 10 being the hypotenuse. X squared plus x squared is 2x squared equals 100. Divide both sides by 2. X squared equals 50. So x is the square root of 50. You can simplify that radical. 50 is equal to 25 times 2. You might recall we can take out a perfect square. So that's why I want 25 times 2, not something like 5 times 10. Neither 5 nor 10 is a perfect square. And the square root of 25 comes outside and becomes 5. So the best final answer is 5 radical 2, or as a decimal approximation, 7.07 inches. Then we have a couple of problems involving something called a 30, 60, 90 right triangle. So if you have a 30, 60, 90 degree triangle, this is a triangle, then we have the rule, the side opposite the 30-degree angle is always half the hypotenuse. Give you a little mini proof of that over here. If you have an equilateral triangle, all three sides are the same. So let's call this is x, and this is also x, 60, 60, and 60 degrees. If I cut this angle in half, come straight down, drop a perpendicular, that means each of these is 30. So I now have a 30, 60, 90 triangle, same thing over here. Then that cuts it in half, so this is half x, and this is half x. So now as you can see, the side that's opposite the 30-degree angle is now half the hypotenuse. So that's what we're saying over here. So we're going to use that in the last couple of problems here. So for 31, you're given this picture, 30 degrees, 60 degrees, x, 5, and h. Well, h is automatically 10 because it's double the 5. The side opposite the 30-degree angle is half the hypotenuse. So if the side opposite the 30-degree angle is 5, that makes the hypotenuse 10. And now I can just use the Pythagorean theorem to figure out x. That's 5, that's 10. So x squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. Subtract 25, x squared equals 75. So x is the square root of 75. I can simplify that as writing it as radical 25 times 3, and the square root of 25 becomes 5. So 5 radical 3 is considered the exact answer. As a decimal approximation, we have 8.66. And finally for 35, you're given this picture, 30 degrees, 60 degrees, 90 degrees, x, h, and 40. Okay, then I say let h equals 2x because it has to be double the x, which is opposite the 30-degree angle. This symbol is an abbreviation for angle. So here's the 30-degree angle, that's x, so that means this has to be 2x because of the rule that the side opposite the 30-degree angle is half the hypotenuse. So I call this x, this is 2x. So I use x, 40, and 2x back in my Pythagorean theorem. X squared plus 40 squared equals 2x quantity squared. 40 squared is 1600. 2x squared is 4x squared. Subtract x squared on both sides. 1600 equals 3x squared. Divide both sides by 3. X squared is 1600 over 3. That makes x the square root of 1600 over 3. The square root of 1600 is 40, so 40 over radical 3. And you might recall from our earlier work with radicals, to rationalize the denominator, I can multiply the top and the bottom by radical 3. That way I have radical 3 times radical 3 in the denominator, which is just regular 3. And the numerator is 40 radical 3. So x, the side opposite the 30-degree angle, is 40 radical 3 over 3. Punch that in your calculator, you get 23.09. And h is going to be double that. So 2 times 40 radical 3 over 3 is 80 radical 3 over 3. That comes out to be 46.19. So again, these are notes for Wednesday, April the 8th for Math 67.6. Tomorrow, Thursday the 9th, we will have 7.7. And then Friday is the Chapter 7 test, Friday, April the 10th.